Look up during a heavy storm, and you are viewing a massive electrical generator. Within these clouds, millions of volts are building by the second. Globally, this atmospheric tension reaches its limit and connects with the Earth about 100 times every single second. A single strike carries the energy equivalent of 80 million car batteries discharging at once. How does a stretch of sky accumulate enough electrical pressure to forge a weapon this powerful? A thunderstorm functions as a high-pressure reservoir for electricity. It gathers vast amounts of energy, holding it in place until the atmosphere hits a breaking point and the current finally snaps through. The process begins deep inside a cumulonimbus storm cloud. Here, warm updrafts of air from the ground are thrust upward into freezing high-altitude temperatures. As temperature drops, water vapor freezes into ice crystals. Winds slam them together, stripping their electrons. Positively charged crystals rise, while negatively charged particles fall. This creates a distinct architecture: massive positive energy at the peak and a dense negative layer at the bottom. This is a massive version of a simple static shock. When you scuff your feet across a wool carpet, you pick up a negative charge. When you touch a metal doorknob, those electrons jump to the metal, creating a spark. The cloud has reached a state of extreme electrical polarization. With positive and negative charges pulled to opposite ends, the entire structure sits under immense tension, waiting to discharge. That heavy negative pull at the base of the cloud begins to pull on the landscape directly beneath it. As we see in this diagram, the cloud's negative base drives the ground's electrons deep into the Earth, leaving the surface with a high positive charge. Because opposite charges attract, the negative sky and positive ground pull each other with increasing force. The air acts as an insulator, blocking the connection and stretching the electric field. When pressure overpowers the air, the cloud sends down a stepped leader, hunting for the surface. The ground responds, sending positive energy upward to meet it. The moment these two channels connect, a massive return stroke rockets upward from the ground into the cloud. Although we perceive lightning as hitting the Earth, the blinding flash is actually this upward surge tearing through the atmosphere. Immediately following the flash, the lightning channel reaches temperatures hotter than the surface of the sun. This diagram illustrates the result. This extreme heat causes the surrounding air to expand faster than the speed of sound. This supersonic expansion creates the physical shockwave we hear as thunder. It is the sound of the atmosphere being torn apart and slamming back together. Lightning is the mandatory release valve for a system that has been pushed past its physical limits. These flashes and booms are the sights and sounds of nature violently forcing an imbalanced sky back into equilibrium.